Hi everyone. Today I will talk about section 4.3 Math 180 Business Calculus. Um, this session will talk about the differentiating of the natural logarithm function. Um, so, um, so as you learn in natural log. Section 4.1 and 4.2 already. And you also learn about derivative already. So now the question is, how can you take derivative of the log function, okay, or natural log function? So question is, how can you take derivative of the natural log function? So we will apply the rule is derivative of the natural log function will be equal to 1 over x. Okay, so you take an x derivative will be equal to 1 over x. Okay, that is rule, and you have to always do that. Now, let's do some example by applying this rule. Okay, so I have example one. In example one here, I have part A. I have fx equal to 7x cubed times lnx, and okay. Part A is saying that let's find the derivative of fx. Okay, so let me rewrite fx first, equal to 7x cubed lnx. And now I know that in this function I have three things. One is 7 is constant, and the other one is the 2 factor here, right? So I can look globally and see that there is a polynomial multiplied with the natural log function here. So I have to use product rule in here, right? So I would like to say this is use and it is v. So if you consider, excuse me, if you consider, say I gonna include 7 here at the 7x cube here at the use, and x at the v. So I will have u times v, and I will apply. Okay, so I will apply the product rule in here to get f divided by x equal to u prime times v plus v prime times u, and you need to have a sidewalk here for u is equal to 7x cubed and v equal to ln x. I may have to move it out here a little bit. X. Okay. So u prime will, or the derivative of u will give you 7 times 3 equal to 21 x to power 2, lower down 1, 4, 3, right? And the v prime will give you I know that ln x derivative will be 1 over x, so I just have 1 over x here. Okay, now time to just apply or just substitute everything. Okay, so I will move up a little bit and maybe I'm gonna clean delete this. Okay, so I will have f derivative of x will be equal to u prime is 21x squared time with the v is, what's the v? Ln of x. And then plus with v prime is 1 over x time u is 7x cubed. And now time to combine things or simplify things. I know that I'm gonna have this term combining, you cannot combine the polynomial with the ln, so you gotta keep 21x squared times ln x, and then plus with 1 over x times 7x cubed gonna be simplified as x gone away, and you're gonna get 7x squared. And if you want to factor, you can factor out 7x squared because that is a great common factor. So you have 7x squared, factor out to get 21x squared here, factor 7x squared gonna be 3 ln(x) plus 1, because when you factor 7x squared out for the second term, now you get only 1. Okay, so that's gonna be the answer for A. Okay, and now in order to do B, what's B? B gonna say find an equation of the tangent line at x equal to E. Okay, so you should know that in order to find equation of the line tangent at x equal to E, you need to find slope at x equal to E. Okay, so slope, we put down this. So slope M gonna be equal to the okay, so I may gonna write at x equal to E, right? So if you want to draw a line, you can just say, okay, fx is a curve in this case, and if you are looking for the tangent line at x equal to E here, so x equal to E here, and then you will get the value of y by applying x value into the function of fx to get the y value, because this point is intersection between the tangent line and the curve. So so you can have y value equal to f of e with equal to what, say 7x cubed, or no, x now should change to become something, okay, time ln of something. Now what is that thing? X equal to E, so I'm gonna change E here, and now I'm gonna have y equal to 7e cubed. times ln e become 1. This is a 1. So I have 7e cubed is the y value. Maybe I don't want to circle this. I have this as a y value. Okay. So now I need to find a slope. So the point in here is e and 7e cubed, right? The intersection point. So I say intersection point is I, right? And a capital I here. And then slope m will be equal to f prime of e. Okay. So remember that the derivative in general, the derivative is slope in general, right? So this is a slope in general, okay? But at point E, okay, at x equals to E, then the slope had to be has to be f derivative of E, because you're gonna plug E into the f derivative of x. So then you're gonna have 7 something square, right? Time with the 3 ln of something plus 1. And what is that thing? I know that is E here. So then f derivative of E or m equal to what? 7e squared time with 3 times 1 plus 1. And okay, so now I will make this go away. And now I will have m equal to 7e squared times 4. So 4 times 7 is going to be equal to 28e squared. So that is slope of the line, of the tangent line. And I need to do what? I need to substitute part e 7e to power third and m equal to 28e square into what? Point slope form, because you are having a point and a slope, right? Let me say point here, right? We have y minus y1 equal to m times x minus x1. So I know that it is x1 and it is y1. And now I am substituting to get the tangent line. So y minus 7e over 3 equal to m is 28e squared times with x minus e. Okay, so this should be the tangent line of the I mean equation of the tangent line in part slope form. So I'm gonna say this is tangent. This is equation of tangent line in part slope form. So then you can stop here instead of I know that some of you maybe just keep deriving this. You can do that by adding, I mean, separate y alone, and then do distribution and combine like term things. But I mean, I don't need you to do that because this question doesn't ask you to change it to become the form for the slope intercept form. So I'm gonna just stop here because I have the question of the tangent line already. Okay, so done for that. Now, the question is, what about question 2? How can I take a derivative of composition function, conversion, and natural log function? So answer is you need to use chain rule for log function. Okay. So what is chain rule in this case? I don't even need this guy, but yeah, I don't even need this one. Just put it down. Okay. So what is chain rule? Chain rule is when you take the derivative of a convolution natural log function here, you will get so the same thing as a chain rule. You are having 1 over gx and then multiply with a z derivative of x, or you are having what is this called? You are having the derivative of outside multiply with the derivative of inside. Okay, so oh, this one. So say derivative of outside function multiplied by derivative. Oh, this is not enough. So I'm gonna change this as outside function derivative here multiply with the inside function and then derivative that. So do an example so you can see it more clear. So example 2, I am trying to take the derivative of fx for fx equal to ln of 5x squared plus 2x minus 7. And in this case, if you look globally, you see that there is an inside function, and the inside function in here is 5x squared plus 2x minus 7. So in this case, you should using chain rule, and and if you apply, so you say that u equal to 5x squared plus 2x minus 7, then you're gonna get u prime equal to what, 10x plus 2. Okay, and this is what this is, inside derivative. Okay, inside function derivative. And for the outside function, outside function will be 1 over the argument, or you can just say f of u equal to ln u. So then it's going to be f derivative of u will be 1 over u. So then when you take the f derivative of x, it's going to be 1 over u times with the inside derivative. But for the 1 over u, in here I'm going to substitute u become 5x squared plus 2x minus 7. So that is the answer. And in short, it should be no, they haven't had answer correctly. Yes. I'm gonna write an answer. 1 second. So let me move this down. Okay, what happened? Okay, so this should be equal to f derivative of x equal to 1 over 5x squared plus 2x minus 7 multiplied by 10x plus 2, right? Because I'm having the inside derivative going to be this guy. Okay, so for this case, I maybe think about, can I factor this guy? I need to check. So I have 5 times negative 7, gonna be negative 35. A times C is negative 35. B equal to 2. Okay, so I need two numbers that multiply equal to negative 35 and addition equal to 2. So I think, yes, I'm gonna have 7 and negative 5. In this case, I have A equal to 5. It's not a special case, so I need to split this, become 4 terms. So I still have to have a side work. So I have 5x squared plus 2x minus 7 will be equal to 5x squared. Okay, now I need to split the 2 here, become plus 7x minus 5x, and then I plus with and minus with 7 here. I just split the middle term, become 2 term, so I can make it become I can apply grouping method. Grouping method say I need to factor the for the 2 terms, for each 2 term here. So first 2 term I can factor x out, and then I get 5x plus 7. For the second 2 term, I'm going to factor out the negative 1, and I'm going to get 5x plus 7. So now I noticed that there is 2 common factor here. I mean, there's one common factor here between two big term, and I can factor it out. And I'm gonna get x minus 1 and another factor. Okay, so it look like I can factor this, but let's see if I can cancel anything. Top, I can even factor it become 2 times 5x plus 1. And the bottom become 5x plus 7 and x minus 1. Okay, so this should be the answer. However, I cannot cancel anything. I cannot simplify more. So sometimes we're lucky that we can cancel, but sometimes unluckily we will not have anything to cancel to simplify. So I'm gonna just stay here at the answer. Okay. Right. Now I'm gonna move to example 3 here. Example 3. So I'm gonna just delete this. All right, example 3. Again, it's giving you another conversion of natural log function, and they want you to do the review of fx. So I will. You can do it by yourself, and then I mean pause my video and do it by yourself and check with my work. So again, I gonna put in here inside function is u equal to x squared minus 4. And then also there is a letter 3 here. Okay, I may have to for this case you need to maybe you need to make it become to power 3 here. So then you have to apply chain rule on this again. So you have u prime will be you know what, I'm gonna change a little bit. Okay, so you can do that, but that's way maybe a little bit long. So I would like to apply the properties of the ln by make the power become the coefficient, the power argument become the coefficient of the ln. So I will make it equal to 3 ln of x squared minus 4. And now you will actually easily have inside function at u equal to x squared minus 4, and take the derivative of that. You're gonna get 2x minus 0. So I'm gonna get 2x only, and I'm gonna label this. Okay, now I would like to have I would like to find the derivative of so I'm gonna have f of u's will be 3 ln u's. So then you will have f derivative of u to be equal to 3 times 1 over u, or you can even rewrite it as 3 over u at the outside derivative. So let me change the color, become this. All right. Now you need to find f derivative of x. So outside function, as it is 3 of u, okay? Multiplied by with inside function, which is 2x. All right, so this one and this one. Okay, now you will get 6x over u's. But u now I actually will change it become x squared minus 4. Okay, so that's be the answer of this problem, and you cannot cancel anything. So let's move down to see more example here. So example 4 is look. So let's look at the example 4 here to see what is the idea. The thing in here is you are having like a the composition, but the thing is the outside and the inside of the function now is actually is an ln, a natural log function. So I would like to say use now equal to ln of 3x. And if I want to take derivative of use, in this case, I have to take okay, so in this case, again, you still have to apply the chain rule in this ln, because why? Because the argument in here is 3x, right? So you still it is not an x alone. So you had to apply the chain rule for this ln in order to take the derivative of that. So you if you apply the chain rule in a quick way to see, you can apply, because this is like a very simple simple one. So you can just take 1 over 3x, okay, because, or I guess because this is argument, okay, 3x is go down here, all right, and you will multiply with the inside derivative. So the inside of this ln is 3x derivative. That will give you 1 over 3x times 3. And I just combine that 3 with number 1 to get 3 over 3x. And now you have 1 over x at the inside derivative, or u prime. Okay, now I will get f of u's with, what is that equal to? I know that f of u is u to the power 4. So then f the derivative of u will give you 4 times u to the power third, right? So then now you need to find f derivative of x, and you can make this, let me change the color, become this. You can make it become 4 times u to the power third. U in here is ln of 3x. So I'm gonna put ln of 3x power third and multiplied by u prime, which is 1 over x. Okay, and if you want to combine it, you should have 4 over x times ln 3x for everything to power 3. And that should be the answer of f derivative of x. Okay. Okay, now I would like to talk about example 5. This also have a composition of natural law. And the problem right now is natural log is under denominator of a fraction. So in this case, maybe maybe you should, let me see, maybe you should think about quotient rule in general, or you can change it to be power rule. Because why? Because in the top of this fraction, it is a constant number. So so I would like to change it become power better. So I'm gonna say 6 times ln of 8x squared, everything to power -1. So okay, so now it's look nicer to me, and I would like to say let the inner right now is u equal to ln of 8x squared, and again this is a convolution function of natural log. So I'm gonna have u prime equal to 1 over the argument in here is 8x squared, and I have to multiply with 8x squared derivative. Okay, so I would like to have 1 over 8x squared times 8 times 2 to power times x. And if I want to simplify, I have 8 here, cancel this 8, and this x squared become x. Okay, so now I have 2 in the top, bottom is x for the u prime or the inside derivative. Now I gotta change f of x become f of u, and it look like 6 times u to power -1. So outside derivative gonna be f prime u equal to 6 times -1 gonna be -6 u to power -1 minus 1 equal to -2. Okay, so then that is an outside derivative. Okay, I'm gonna label this guy, and I will have f(x) derivative equal to outside derivative is -6 used to power -2. What is used? I need to make it bigger. Use is this guy. So I will have ln of 8x squared. Okay, and then I multiply with u prime, or the inside derivative, which is 2 times x, 2 over x. Okay, now let's simplify. And derivative x will be equal to, so -6 times 2 equal to -12. Okay, and then I would like to change the ln of 8x squared here, and to power -2 here become positive power. So I'm gonna multiply by 1 times ln of 8x squared, everything power 2. Okay, so maybe I need to have parenthesis here and parenthesis here, and then multiplied by 1 over x. And if I want to do one more time simplify, I will get f equal x equal to -12 on the top, and bottom had to be x time with ln of 8x squared everything squared. And this should be the answer of this example 5. Okay, how do you feel? Let's move to example 6 here. I would like to to talk a little bit about implicit differentiation. So let me see. You know what? I would like to spend this example 6 to example 7 and 8 here in another video. So I would like to stop this video at here and talk to it in another video. I see you next time. Okay. Have